Okay, in this example, we're going to look at 3 different force vectors that are applied to a free body diagram. And what we want to do is we want to find the resultant, or if I cast a wide net and gathered all these vectors up together, what one vector could I replace it with and at what angle? And then what would be my equilibrium, or what would be the vector that would cancel out this vector? So that's what we're going to be working on. I'm choosing 3 because 2 is easy to do. You can use a parallelogram method. There's a couple different ways that you can do it. But with 3, if you can do 3, you can do 4, 5, 6, 10, however many forces that you have. So the first thing that we're going to do is we're going to make sure that all angles are with respect to the positive x-axis, because we're going to do some trig here. And so if we do it to the positive x-axis all the time, we don't have to think about the math, and it will automatically give us the correct signs every single time. So this first one, this 30 degrees, is already with respect to the positive x-axis. So I'm going to say 30 newtons at 20 degrees. So we're in good shape. This one is going to give me a little bit of a headache because this 40 newtons is 45 degrees from my negative x-axis. So we know that this negative x-axis is 180, and I need to back off of that by 45. So I'm going to do 180 minus 45, and I end up with 40 newtons at 135 degrees. And then the last one, I'm looking at this guy down here. I know it's 10 degrees away from this vertical, and I know that this is 270 degrees. If you do not know your angles, please make sure you know those. So this is 90, this is 180, and this is 0 and 360. So it's 10 degrees off of 270. I'm going to back that out by 10, so that gives me 25 newtons at 260 degrees. So now I have all of my angles with respect to the positive x-axis. So from here on in, it's super easy. I'm going to make my XY chart, and I'm going to do my X and Y components of each of these vectors. Because I already have them listed, my X is really my cosine, and my Y is my sine. Okay. If you have your angles with respect to the Y-axis, then those would be different. So here's my X values. I've got 30 cosine 20 degrees. And then my Y value is going to be 30 sine 20 degrees. Then the next vector will be 40 cosine 135 and 40 sine 135. And then my next one is 25 newtons. 25 is all I need. So 25 cosine of 260 and 25 sine of 260 degrees. So do make sure that your calculator is in degrees, right? When we do vectors, it has to be in degrees. This is not a radians or unit circle type of situation. So what I'm going to do is in my calculator, I'm going to go ahead and add all of my x's up, and I'm going to add all of my y's up. When you enter it in, you're going to want to do parentheses and then hit 30, then cosine, which will bring up automatically another parenthesis. You put in 20, close that off, close it again, and then hit plus, and then keep going with the rest of those. By having everything with respect to the positive x-axis, it automatically selects which one needs to be negative. So when I add up all my x's, I get negative 4.435 newtons. And when I add up all my y's, I get 13.925 newtons. And then finding my resultant is really just closing off the hypotenuse of that triangle. I have my x value and I have my y value. So my resultant is going to use my distance formula. So that's going to be the square root of x squared plus y squared. So in this case, it's going to be negative 4.435 newtons squared plus 13.925 newtons squared. And you should end up with a resultant of a value of 14.614 newtons. So that is good so far, but I need to know what angle it's at, because if I want to figure out what force would cancel it out, I need to know what angle that one's going to go. All right, so we know that when we have a triangle, if we know our y value and we know our x value, to find that angle, it's going to be my opposite over adjacent. So that angle is, the tangent of that angle, is equal to y over x. So in order to separate out that tangent from that angle, I'm going to take the inverse tangent. So that angle is going to be the inverse tangent of y over x, which is going to be the inverse tangent of 13.925 newtons over negative 4.435 newtons. And that's going to give me an angle of, let's see here, we've got a negative 72.3 degrees. All right, now with a negative angle, here's where we got to do some magic so that we know exactly where it sits. I need to look to see what quadrant my answer is in. If I have a positive y and a negative x, that means that I am in quadrant 2 for my resultant vector. So we're going to do a little bit of finagling here, I guess. If you're in quadrant 1, with respect to that angle, you don't do anything. If you're in quadrant 2, you're going to add 180 degrees to your angle. If you're in quadrant 3, you're going to add 180 degrees to that angle. And if you're in quadrant 4, you'll also get a negative angle, so you're going to add 360, and that will tell you what angle you actually have. So my angle, if I take negative 72.3 and I add 180 to it, my angle is actually going to be 107.3 degrees. So I have my resultant, which is 14.614 newtons at 107.3 degrees, which is in my second quadrant. To find my resultant that will put this into equilibrium, I want to go ahead and add 180 to this. So if I add 180 degrees and keep the same resultant, then it's going to be 14.614 newtons at 107 plus 180 gives me 287.3 degrees. So this would be my equilibrium.